Hello. Can everybody hear me okay? Okay, wonderful. Welcome everyone. I am Maddie Basil from Swarthmore College, and I have the privilege of introducing our next little segment, the keynote address. We have with us Jennifer Thompson, a chief data scientist with Devoted Health. And I'm not going to waste any time. I'm just going to turn it over to you, Jennifer. Thank you so much for sharing your research with us today.
Okay, great. It's so good to be here. I really appreciate Dr. McConville for inviting me. I've told several people how cool I think this idea is and how great it would have been to have this conference when I was an undergrad. So I'm so glad that you're all here and really excited to be here myself. Today, I'm going to talk about finding your balance, which I admit sounds like a yoga class. But as much as I love yoga, we are going to talk about it in terms of statistics and data science. So what it looks like to strike the right balance between building foundational knowledge and also evolving in our skill sets and how we might be able to get there. So there are two types of people in the world, which is actually completely untrue, but I've noticed that everyone falls somewhere along this continuum. Some of us really like stability, security, expertise, this idea that we're comfortable with and with what we know and we're good at what we do. We like building this foundation of expertise. We like applying reliable methodology to solve problems. And we really value building long-term relationships with our colleagues. We become experts in the domain that we work in, whether that's healthcare, biology, manufacturing, tech. We might be skeptical of the hype of like shiny new tools because we know that our foundational training will get us really far. And those new things might be a time sink without much benefit or have risks we haven't considered. But some of us really like chasing those new things. We are always looking to learn new methods or additional technologies. We're learning and doing new things sounds really fun, and we're always looking for ways to improve our work. We feel like staying too long in one role makes us stagnant, and we like the new knowledge, the new connections and relationships that we build as we work in different areas. We feel like trying a lot of new technologies or types of work gives us a broader path to progress in our career, or maybe new and exciting directions in the work that we're doing. So by nature, I lean a lot toward this stable end of the spectrum. I think the tried and true methods get us really far, and I personally would rather develop strong expertise in one programming language, for example, than be a dilettante in a lot. I'm kind of skeptical of chasing far-fetched hypotheses or tools, and I get really excited about building tools, analysis, relationships, and domain expertise with an eye towards the long term. I think that helps me build better analyses with more business impact. And these are all very good things. But I've seen in my own work and career and that of others around me, how those things that are all often very good can also sometimes hold me back. Whether that looks like work that's good but could be even better, or a career path that's good but maybe needs a change. So I've learned to take a page from my friends and my colleagues who are more excited by these new things, to choose that path of adventure sometimes. It's led me to better analysis and programming practices, to fun projects and new ideas. It helps keep my career fresh and my work the best it can be to evolve in my thinking and my skill set. And at the same time, I've seen lots of people whose tendency is to go after those new things, who are excited by change or new technologies or applying the newest methods. I've seen them benefit by focusing more on building foundational knowledge, on digging into a specific set of methods or tech or domain. And it's hard to make real solid progress if you're always chasing that adventure and excitement. So it's true that I learned from my adventure-seeking friends how to enjoy learning new things and being a beginner sometimes. And it's also true that sometimes it's better to step back, to do the simplest version of the hard thing, and to let your foundational knowledge drive your plans and your choices. So today I want to go through some examples of how we need to balance those tendencies. I crave stability and adventure in different parts of my own life. And while you might always be someone looking for adventure, maybe you have teammates who are a little more feet on your ground types, and I've seen how that can be a really killer combination if we learn to appreciate each other and each other's strengths and contributions. So we're in an era where data science and statistics programs are proliferating like wild. Job titles involving the word data have this almost mystical quality in some circles. You can read Wired articles that give you the impression that data science requires a literal degree in astrophysics. But at the same time, we all need a solid grounding in things like experiment design and linear regression in order to create trustworthy and useful data products. So I found that these two things are simultaneously true, that straightforward, reliable methods, things like general linear models and survival analysis, exploratory data analysis, and a really solid grounding in experiment design, these things will get you really, really, really far. I've seen an entire business built on logistic regression models. And this is great because when conditions are right, these methods are interpretable, they're reliable, and they're powerful. But in some cases, those tried and true basic methods will only get you so far. So my background and training are in biostatistics, which means that I was trained in applied statistics with a particular emphasis in experiment and study design and analysis methods that are used in medical or pharmaceutical research. And when I finished my graduate work, I initially went into academic medical research. I worked as a biostatistician on clinical trials and observational studies that focus primarily on ICU patients, the sickest of the sick at our medical center. And I worked with this ICU research group for over a decade. Together, we published about 50 research papers, many of which had a ton of impact in the critical care community. And I say that because I want to emphasize that some of our most clinically impactful work was done using decidedly traditional statistical and epidemiological methods. And these traditional methods can kind of get a bad rap sometimes. People call them basic like it's a bad thing. If you look at Kaggle or Twitter, it can feel like a competition for who can use the fanciest algorithm. If you use just regular old linear or logistic regression, surely you somehow haven't done enough. But there's power in using these methods when you can use them well, when you understand their capabilities, their assumptions, and yes, their limitations. So rather, I think of these methods as basic like IKEA furniture. They're often really attractive in their simplicity, they have lots of hidden benefits, and they're exactly what you need sometimes to get you really far. So I moved to a new city earlier this year, and it was actually cheaper to buy new stuff than to ship my stuff cross country, which means that half my apartment is currently furnished with IKEA. And you know what? I really like it. It might not be what I want for every situation, or maybe even permanently, but it's straightforward, it's functional, has a lot of non-obvious benefits, and it totally serves my everyday needs, even if everyone else in my building is using the same thing. So I saw this tweet from Angela Bassa, who's the director of data science at iRobot, while I was preparing this talk, and I thought it was so perfect. Everybody thinks they want revolutionary solutions, but what really makes the world go round are dependable, helpful, and credible ones. And her tweet has been so true in my experience. So this is called the Brain ICU Study. This is one of the major papers that I published with my research group at Vanderbilt, where I worked for about 13 years. It was a really big deal in the critical care space because we were among the first people to show how the cognitive function of ICU survivors could really take a beating after their illness. We started this study because the clinicians that I worked with, along with their critical care peers, saw a lot of ICU patients who 20 years before might not have even survived their critical illness, now surviving in much higher numbers, which of course is great. But they were often surviving the ICU only to struggle to recover and get back to their normal lives, both physically, but sometimes even more important to the patients, mentally. So in the clinicians that I worked with experience, patients who came into the ICU with normal brain function were leaving unable to return to full form at work or handle their finances. And we weren't sure if they would recover or how we could prevent this experience from happening. So our group designed an observational cohort study. We enrolled 821 ICU patients at 2 medical centers over the course of about 4 years. We collected information and assessed them every day while they were in the hospital. And then once they were discharged, our neuropsych team worked incredibly hard to contact and assess as many patients as we could. We started out assessing them 3 and 12 months after they were discharged. On its face, this is a really simple design. We enroll people, we assess them in the hospital, and then later after they're discharged. And then we look for relationships between their experience in the ICU and their experience as they recovered. So in addition to that straightforward study design, we also ended up taking a straightforward approach with our analysis. We assessed patients at 3 months after their critical illness, which according to our neuropsych experts is still short-term recovery in this scenario. And then again at a year after their illness, when patients were likely to have settled into their long-term new normal. Our outcome was a normalized score, therefore normally distributed, and so we ended up using just one linear regression for each time point and treating them as separate outcomes. So basically, we ended up conducting a study with very traditional design and methods, and instead we spent our energy really focusing on getting some basics right. For example, who are we really trying to study? Basically, who do we include, who do we exclude? We wanted patients who were really, really sick, but how do you define really sick? Getting those population definitions right is absolutely key for a usable, generalizable, and interpretable project. Another question we addressed was what data do we need to collect? In prospective clinical research like this, we have the luxury of being able to specify the information we're going to get, and our research coordinators are absolutely amazing at getting that data. But we had to think carefully about what instruments we would use to assess cognitive function or pre-existing conditions. There are multiple options out there. and what potential confounders we needed to be able to account for when we did the analysis. There are also lots of options there, and we needed to optimize for not only complete information, but also for the burden on our patients, their families, and our study staff when we collected that data. In these prospective clinical research studies, many of our data points are hand collected, and it's a massive undertaking and can take a lot of time for both our staff and the patients and their families. We thought a lot about what statistical methods we would use, because even though we had this simple study design and used linear regression, we of course had confounding to deal with. Our group has a focus on monitoring and studying delirium in ICU patients. And as one potential risk factor that we can actually modify about an ICU stay, instead of, say, someone's age, we were particularly interested in looking at whether there was a relationship between the delirium that a patient experienced in the ICU and then their long-term function. But what happens if our older patients were both more likely to experience delirium and more likely to experience that decline in cognitive function? In that case, it's hard to untangle that causal relationship if it exists. So we spent a lot of effort designing data collection protocols that allowed us to proactively account for our most important potential confounders. How do we build our model? There are lots of different approaches to model building, but in this case, we had a defined research question, and our primary aim was to make inferences about our population. We needed to be careful to build a model that would generalize to a similar population in other medical centers or even in other countries, rather than finding relationships that turned out to be noise that was specific to our study cohort. So in our case, that looked like pre-specifying our covariates for full transparency and reproducibility with minimal risk of overfitting. And of course, like most projects, we had bias in our data, despite our best efforts. In addition to population loss due to death in the ICU, we also had differential dropout. Our follow-up team told us that we were more likely to have incomplete or missing test results from our patients who were the sickest. Lots of times they were just too tired to complete or even start an assessment, even if they did survive the ICU. So even though our intention was to inform clinical care at the point of admission in the hospital, the population that we ended up testing in the long term was not perfectly representative of the population that a typical clinician would encounter when she looks at her entire ICU census on a given day. So we thought carefully about where bias might be coming from and how to mitigate its effects, using both statistical techniques for missing data and also just very careful interpretation of our results. So we spent a lot of time within our group talking about our multivariable model that looked at potential risk factors for long-term cognitive detriments, making sure that we could account for all that confounding for things like nonlinear relationships between our covariates and outcomes, and making sure that we were handling that missing data correctly. This figure shows that relationship between delirium and our long-term outcome. The upshot is that someone with 5 days of delirium during critical illness has, on average, cognitive function that is meaningfully worse than an otherwise identical patient who did not experience delirium during their critical illness. That was a key finding from the study, and it's gone on to both inform clinical care, which has shifted over the last decade to focus much more on prevention of delirium, and future research on delirium prevention and treatment. We took a lot of care in presenting this finding in as straightforward a way as possible, and I think that paid off. But one of the biggest lessons I learned from this paper was about the impact of simply describing what you see. It's insufficient for many analyses, yet absolutely necessary. In every talk and tweet that I've seen that reference this paper, it's not always this figure from our model with our model results that gets shown. Instead, it's this straightforward set of box plots. On the y-axis, I put our primary outcome, which was a score called the R-bands that measures global cognitive function. And on the x-axis, we have each combination of our outcome time point, 3 or 12 months, and patient age and enrollment. For descriptive purposes, we bucketed them into younger, middle-aged, and older patients, even though in our model, we included that as a continuous covariate. So in terms of methods, it's as simple as it gets. But in terms of impact, this figure is huge. And it's huge because we have quality data that shows that even though we explicitly enrolled only patients who were at normal baseline cognitive levels before their illness, who likely would have fallen into this green zone, which indicates a normal range, after they were discharged and physically recovered, 3/4 of even our youngest patients had cognitive levels that were lower than what we consider normal. And 1/4 of our oldest patients, all the way there on the right, had cognitive scores that resemble those seen in Alzheimer's patients, which is indicated, that score, that norm is that purple line. No one else had the ability to describe in detail, in a sizable patient population, what these patients were experiencing. And that description made a huge impact in the critical care community. It meant that this patient experience and its ramifications for both individual lives of patients and for our society are something worth focusing time and resources on. In fact, one of the impacts of our brain ICU study was that it helped us make the case to get the resources we need to conduct the Mind USA study, which is what this paper represents. This was a randomized clinical trial, which looked for differences between a placebo and 2 different medications, 2 different antipsychotics that are used to treat delirium in ICU patients. So thanks to ours and others' research, ICU clinicians know that delirium is bad for their patients. But unfortunately, there's no strong guidance on how to actually treat it once it happens. So a lot of times patients will get one of these 2 medications or others like them because they're the only known option, even though they're off-label. But no one actually knew if these worked, which is what we set out to learn. This is the last project I worked on with that group, which we published about a year ago. I'm really proud of it for a number of reasons. As with the last study, we spent a lot of time planning our study design and how to actually execute the trial. We did this in both cases because no matter how complex or modern your statistical methods are, you can't statistics your way out of every problem. When you can, it's much better to design your way out of having the problem in the first place. Thanks to being able to control a lot about our study and the attention we gave to careful study design and execution, we were again able to use straightforward, reliable statistical methods for our primary outcomes. Remember, we're going for clinical impact, not statistical fanciness. And in your case, you might be going for business impact, the ability to make a decision about the direction of a product. If you can isolate what you're studying via good experiment design, if you can remove sources of bias and potentially faulty assumptions, you can use those powerful yet straightforward methods that give you the exact answers you need. But sometimes that level of control and simplicity just isn't possible. Maybe it's not ethical to randomize people. Smoking is, of course, the classic example. You can't randomize people ethically to smoking versus non-smoking. I currently work at Devoted Health, which is a Medicare Advantage healthcare plan. We are an alternative to traditional Medicare for primarily older Americans. And if we want to learn whether a particular benefit improves our members' health outcomes, we generally can't legally or ethically randomize some members to get the benefit and some not. And if you can't randomize, your t-test or your ANOVA is no good here. And maybe you have a major source of bias, maybe informative dropout like we had in Brain ICU, or something like a survey where there's a group that's likely to be underrepresented in your sample compared to the actual population that you want to learn about. Maybe you weren't involved in the data collection or the study design. You're coming in at the end of a project, you're being asked to do the best you can with it, but you know that the data you have access to is biased or has other issues like missingness, or maybe just doesn't exactly answer the question that you're trying to answer. And of course, sometimes life is just complicated. So here's one example of how my skills needed to actually evolve in order to solve my problems. In Mind USA, for some of our outcomes, the methods I was already familiar with just weren't sufficient. There was an additional source of complexity that our group hadn't confronted in quite this way before. Several of our outcomes in this trial were what we call time to event outcomes, meaning that we're interested in something like how long it takes until our patients, the vast majority of whom entered our study needing the help of a mechanical ventilator to breathe, how fast they were able to come off mechanical ventilation and breathe on their own. But unfortunately, this population is also so sick that many of our patients died before they ever had the chance to come off the ventilator. So in this case, death is what we call a competing risk for the outcome that we're actually interested in. Our population is changing as we observe it. And if we didn't take that into account, our results would likely have just been wrong. There are statistical methods for handling competing risks, but I myself had never used them, not because they were fancy and brand new, they weren't, but they just hadn't been required in my work up to that point. So it was time to learn something new. I worked with my supervisor to research the specific method we were interested in out of a few different possibilities, and to make sure that I understood it well enough to both execute and explain it. And when we knew the time investment was worth it, which it absolutely was in this case, it was a lot of fun. I was getting to flex a different muscle, to learn a new technique. And now that I'm in a new environment at a healthcare company, we have different types of data, we have different business goals, and I'm learning a lot about different approaches to data work from my colleagues who are experienced in fields like healthcare economics and machine learning. And it's been a great way to question my assumptions and augment my experience with new ideas. So far, we've talked primarily about methodology, but we have to execute all this methodology somehow. And in what is probably no surprise to most of you, the tech that we use as statisticians has become just as important as the statistical methodologies that we execute with it. Most of you are probably learning 1 or maybe 2 programming languages right now. This is awesome. Learn it well. It will help you in so many ways. In the last year, I've switched from years in an R-heavy environment to a job where I'm now learning 2 or 3 new languages. Our department at Vanderbilt was multilingual, but pretty R-focused. And our tech stack it's devoted right now is primarily Python and SQL on the data side, plus Go on the engineering side. So this is something quite fresh on my mind and close to my heart right now. R was my preferred programming language and that of most of my coworkers for years. And by digging into R and focusing on one primary language for a long time, versus learning bits of lots of different technologies, I was able to learn the fundamentals of programming in a statistical and analytical context. And I think when we do this, we could become both faster and better at our work. And to be absolutely clear, the same can be true for any language. R happened to be mine for a good long while, but these concepts hold true for Python or any other language too. So in my context, the specifics look like learning how to set up my projects and therefore my future self up for success. This will have a tremendous effect on the amount of pain or joy that you find when you inevitably revisit a project months after you think you're finished. Basics like thoughtful file structure and code comments will get you so far. And using more advanced techniques like version control and virtual environments, these are great next steps. Those concepts have all served me so well in every language that I've learned. And also in moving from a context where I'm usually the only person working with my code to a context where literally everyone on our team can and does make contributions to the same code and projects. I also learned how to write more efficient code. Whether you're doing statistical simulations, probabilistic programming, even more basic things, all of these things will benefit from learning how to write not only successful code that works, that does what you want it to, but also efficient code. Even for something as basic as cleaning data, this matters. Years ago, one of our systems analysts at Vanderbilt helped me take the approach that I was using for a data cleaning script and cut it down from taking hours to taking minutes. And I always learned a ton from collaborating with him, but that instance will always stick out because he helped me understand the fundamentals of vectorization, which made everything I did go faster. So one core tenet of programming, just general programming, is DRY, don't repeat yourself. Meaning if you find yourself doing roughly the same thing over and over again, you should really consider writing a function to do it. I have a very visceral memory of a project several years ago where I had not yet learned that lesson. The hours and hours I spent copying, pasting, and changing 2 or 3 things in a chunk of code are hours of my life that I will never get back. Aside from the time wasted, of course, it's a huge opportunity for errors to sneak in. So fairly soon after, I started learning how to write proper functions. I learned about environments and scoping and object-oriented programming. I also learned how to create and disseminate a successful data product that's consumable by different audiences. This can look like a visualization that's both informative and clear, or using literate programming like R Markdown to create an analysis that's both reproducible, transparent, and transferable to other analysts. And it also creates the document that just tells my collaborators, what's the point? What do I need to know about this? But before we get to that point of communication, of course, there's so much prep work, tons of data wrangling, and how much you do depends wildly on your context. But we will all spend a huge amount of time doing this in order to get to that point of modeling or visualization. Data rarely comes to us in a perfectly formatted CSV file. So we need to figure out how to pull it out of a database, how to combine data sets, how to turn a wide data set long or vice versa in order to get to the point where we can, to quote one of my current coworkers, science the data. The specifics of how we do this differ depending on the tech stack that we're using, but conceptually it remains the same. And developing a workflow and a solid mental model around this helps us immensely. But eventually, we'll almost always need to move beyond the bounds of one tool. Enter 2019, when I, with my expertise in R, started a new job at a company where our data is stored in a data warehouse, and our primary tech stack right now is in SQL and Python. For any of you not familiar, SQL is the primary language in many contexts for data extraction and management. But because of how our data at Vanderbilt was stored and the tools that we'd use in my previous role, I just never used it. My second week on the job, my manager said to me, my only goal for you this week is to learn SQL. To which I replied, all of it? And he said, yes, you will be fine. And the thing is, he was completely correct. I learned enough SQL that week to carry me through probably 80% of what I need today. And the reason that I could do that was that I had a grounding in the concepts already, in the fundamentals already. I knew how to join data sets, how to filter, how to reshape. I needed to learn SQL syntax, which let's say has its own flavor, but I knew how I wanted to approach the problems I was solving, and that is more than half the battle. And of course, even if we do primarily stick to one tool, we don't just learn a language once. Languages evolve. Just like English sounds somewhat different today than it did 100 years ago, the R code that I wrote last year is quite different from the code that I wrote 10 years ago. And part of that is my own growth, and part of it is R's growth. If you follow open source software at all, you know that new packages and new capabilities come out constantly. It can be a little overwhelming to try to keep up with everything, which is something we'll talk about in just a bit. But just like we've talked about for new methodology, having a strong grounding in the fundamentals in your context can help you look out for new concepts that'll be helpful to you, helping you separate out the, this is super cool, but maybe not quite worth my investment at this point, versus like, oh yeah, that'll make a huge difference in my work. I should really spend time digging into that. So a couple of examples to contrast. When I was first learning R, a colleague of mine was using an add-on packages for working with dates and times, which are of course the bane of every programmer's existence. And I assumed that because she used it, I should use it too. And it was going great until an update to base R meant that suddenly all my code using that package stopped working. It held up my work for days while I fixed everything using just base R functionality. And in retrospect, my particular needs at that point were just not deep enough to justify that extra complexity. Base R actually did everything I needed. And in my case, the trade-offs just didn't make any sense. But because I was new to the language, I didn't realize that yet. I chased this rabbit trail that ended up costing me time in the long run. But on the other hand, there are lots of tools that made total sense for me to learn and invest time in. And I'll take those literate programming tools like R Markdown as one example. And if you're not familiar with literate programming, it's the concept of interweaving computer code, whatever language it is, and human readable text, so that you have detailed code comments or explanations of your process, maybe even entire scientific or business reports, all written right next to the code that generates the results. So when I was first learning R, the Sweave or Sweave package was really the only option for literate programming. It's a tool that interweaves chunks of R code within LaTeX formatted text to create a PDF report as the output. It's great at what it does, and it was a huge advancement over the tools that were available at the time. But fast forward to the advent of R Markdown, which allows you to interweave Markdown formatted text, which is much simpler than LaTeX, with chunks of R, Python, SQL, or code in other languages. And even better, you can create multiple types of output, like a PDF, a Word document, even an HTML document, so that there are now whole websites built on top of R Markdown. So this was something that was absolutely relevant to my daily work. It's a report built on literate programming tools was almost always the end product of the work that I was doing. So as the new tools came out, the foundations I built by learning the concepts of literate programming allowed me to quickly adapt what I was doing to take advantage of the new capabilities, and also to figure out what specifics would be useful for me to learn and what wouldn't. For example, I built a dashboard on top of R Markdown for monitoring our clinical trials, but I never took the time to figure out how to integrate our Shiny package into that toolkit, because Shiny is kind of its own different animal, and it just didn't add enough value for us to justify the time that I would have spent learning and setting it up. But learning Markdown itself, and a little bit of HTML has served me extremely well in developing products that are more useful and more informative for both me and my non-data collaborators. Of course, sometimes, whether because of a change in our environment or in our needs or even wants, though, it's time to learn a new tool. For example, in my old environment, I didn't need to integrate my code with anyone else's. It's pretty much in a box by myself. But at Devoted, our code needs to mesh well with code written not only by data scientists, but also by our data engineers and our software developers. So we're starting our data work with Python because it's a more general tool that's known by a lot of our tech team. My context is changing, and therefore so is the tool that I need to do our collective best work. And a lot of the concepts in Python are already very familiar. I have a mental model for them already. So what I'm learning is the way that Python expresses those concepts and where it handles things a little differently. And it is a little unnerving to go from expert in one language to brand new in another, but it's also been really beneficial. I'm getting a different perspective on how I code. I'm learning how another community does things, and that gives me new ideas, and it makes my code better and stronger. It's also really fun to learn new techniques and approaches. It injects fresh energy into my work. So up till now, it kind of feels like I've made conflicting assertions. Number one, we should learn the basics. Fundamentals are awesome. Number two, we should learn new things. Don't stagnate. And sometimes it feels like these can be in opposition to one another. So how do we figure out when it's time to dig in, when it's time to stick to one thing and really build our expertise in it, and when it's time to build on that knowledge with a new tool or approach? How do we balance ongoing learning and growth with this never-ending black hole that can be keeping up with the data universe? How do we balance building up our expertise with the potential for stagnation? And there aren't simple answers, of course, to this. It's all context dependent. So I found it useful to basically think about potential consequences when making these decisions. For example, if you do the simplest known thing, what potential benefit are you losing? Does that potential benefit make the investment in a new tool or approach worth it? But on the flip side, what do you gain by sticking to the simple approach? Maybe you gain time because you don't have to learn something new, or interpretability, or ease of collaboration. Likewise, if you spend time learning or implementing a new method or technology, what burden are you adding? Is that potential benefit worth the additional time spent learning that new tool, or maybe the difficulty in interpretation from using a method that you're getting familiar with, or that's just generally more complex? On the other hand, maybe a little bit of investment upfront removes a larger burden in the future. For me, version control is an example of this, using Git and GitHub. It takes a while to learn, but understanding it has saved me a ton of time and frustration. So maybe let's talk through a couple of examples. In the case of our brain ICU project, we actually considered doing more complicated longitudinal analyses. But because in our original study, we only had 2 time points, this really wouldn't have given us any benefit, any new information over a more straightforward approach. It would have actually added time and complexity in our interpretation, and possibly made people trust us less. In clinical research, sometimes we run into people who don't trust fancy math, quote unquote, as much as they do something that they can understand easily. And of course, that doesn't mean that you shouldn't do the fancy math, but it does mean that you need to be able to explain why it's appropriate. And in that case, we just didn't have a strong justification. This is exactly, I think, what Angela was saying in her tweet. In this case, the more complex approach wouldn't have added enough benefit to be worth that additional investment. But in the case of our competing risks analysis, though, using that simpler version could have gotten us just a straight up wrong answer. And we knew that because we understood the assumptions of the simpler version and when they were violated. Using that new to me method was absolutely worth the time that I invested in learning and testing it, including the time I invested in developing clear explanations. But sometimes this is a really tough choice. In a model that I worked on early at Devoted, I had to optimize not only for correctness, but also speed. We had a business decision that we needed to make quickly. In my previous academic life, I would have worked for a while on feature engineering, getting context, making sure I had the details right, making sure that the data product I produced was as polished as I could get it, because this would be published for posterity. But in a business context, I did a perfectly solid first round that I was confident in, but then I had to move on. The time spent polishing those details would not have actually changed our actual decision, and that time was more valuably spent on a new project. So this is all really situational, and knowing the consequences of your choice is key. From a technology perspective, again, context and trade-offs, those are everything. One language or tool might have a little bit of an edge over another for a specific task, but is that edge big enough to make the investment of ramping up in a new language worth it to you? Sometimes it is. For example, when I learned ggplot2 in R, it took some time at the beginning. ggplot2 has a very specific way of thinking, but it makes it much easier in the long run to create really powerful, clear visualizations really quickly. But again, sometimes it's not. My Shiny skills are basic at best because it's just never been worth the investment in my personal context. And sometimes we just need new tools to handle changing data needs. Maybe you used to do analytics and now you're moving into machine learning. Maybe you're changing jobs and they use a different tech stack, hypothetically, of course. In my case, I went from an academic environment to a tech industry role where I now need to collaborate with not only other data scientists, but also our engineering and infrastructure teammates. So the conceptual aspects of my work are similar, but the technical tools that I use to execute that work are wildly different. So to go back to that furniture metaphor, IKEA will get you pretty far. But at a certain point, you'll probably think about getting new furniture. So what's the cost and what's the benefit? If I'm thinking about a bookcase, I'm perfectly happy with IKEA, to be honest. You can customize your way to exactly what you need from the IKEA catalog, and they look pretty darn good. But if you're looking for a couch, I can tell you from sad personal experience that the options at IKEA are pretty depressing. You might start off with a futon and that might work for a while, but eventually you're going to want to upgrade. So now that we've established that at least sometimes we should learn new things, how do we do that? Just saying learn something new sounds fun and easy, but how do we actually go about it? So I start with osmosis because many times you're sort of absorbing new things from the air. Maybe you hear about new techniques from colleagues, or you hear about new tools from programming communities. This might look like regular workplace continuing education, like seminars or journal clubs, or a Slack channel where you and your coworkers share articles, having a list of statistics or data people that you follow on Twitter. You might pay close attention to them, you might not, but this process helps you build awareness of what's out there. The goal for me with Osmosis is to basically have a cloud of options when you need a new tool or approach. And then once you've head in a specific direction, there are tons of options for more active learning. I've done this through conferences like this one, continuing education courses, book clubs, journal clubs, online courses, YouTube videos. Again, you might or might not use the new tool or approach right away, but building your awareness is key so that when you're confronted with a new scenario where you need to learn something new, you're not starting from scratch. You have direction, you have a sense of how to get started. In the case of me learning competing risks, I'd been hearing about them for a long time from coworkers who worked in areas like cancer, where this is a big deal. And I'd also gone through a book on survival analysis with a group of coworkers. So even though I hadn't used this method before, it meant that I had a sense that what I already knew wasn't sufficient in this case, and I had a starting point for learning how to address those issues. So when you start to learn about a new tool or method, I found it's helpful to figure out how this new thing compares to the thing that you already know. So in that case of competing risks, I had foundational knowledge about the methods I was already familiar with. When were they reliable? When were they limiting? How do we interpret them? I thought a lot about how to interpret the results of our competing risks analysis compared to a traditional Cox time to event model. How is it the same? How's it different? How did my standard explanation of what we saw in our model need to be tweaked to make sure it was correct? As you learn the new thing, you're building this mental model. You're putting the knowledge that you're getting into buckets so that you can organize it. Comparison to what you already know also helps you more fully understand what those trade-offs are, what those trade-offs would be of using something new that you need to invest in learning versus using the thing that you already know. Now, if you're someone like me who by nature tends to stick to what you do already know, having a source of authority to guide you through this uncharted territory is incredibly helpful. Someone or some resource to help calibrate you when you're trying things out. If you're someone, on the other hand, who tends to chase the new things with abandon, this person or community can serve as a bit of a reality check. Maybe when the new thing might not be quite the magic tool you think it is, for example. That new open source package might have a tutorial that makes it look perfect. But is there someone you know or something you can read that also talks about some of its bugs or flaws? When I'm learning a new technical tool, there are so many resources that it can honestly feel a bit overwhelming sometimes. I'm not sure if you've noticed, but people very often have opinions on programming languages or tools, and it can be tough to wade through all of that. So figure out who your trusted sources are. I'll pay more attention, for example, to a post that my coworker shares than a random tweet that the algorithm shows me, because it's from someone I'm connected to that I trust, and it's more likely to be immediately relevant to my personal interests. So if you're convinced that this new method or tool is worth your time and effort, there's no better way to learn it than just by jumping in. So in my case of competing risks, I ran models using our traditional approach and a few variations on the new approach, because of course, as it turns out, there's more than one way to handle competing risks. I did that to make sure that I understood where the approaches diverged and what exactly I was getting out of the software when I ran the models. I took a lot of notes during the process to make sure that I not only got it the first time, but would remember it later. And I collaborated with my supervisor on those notes to make sure that we were on the same page about approach and interpretation. So one warning here, for many of us, it is really tempting to try to learn everything, but that is just not realistic. There's so much happening in the data world right now, in so many different subsets of our field, it can feel overwhelming to keep up with everything, especially if you tend to be a completist like me. I am someone who finished the entire series of Lost even after it started to get bad because I need closure. I cannot leave a Slack post unread. Imagine me trying to keep up with data science methods and technologies on Twitter. It's a never-ending recipe for anxiety and imposter syndrome. This feeling of, I don't know everything. What am I even doing here? How will I be a real data scientist if I can't build a neural network from scratch? This is all very, very real. So what I work on is figuring out my personal balance between keeping an eye on things that might be useful, but not sinking time or anxiety into trying to learn all the things. So I do use Twitter for both connection to other data folks and for that osmosis, but I use lists to organize my feed. And that's been a game changer. My Twitter feed used to be a fire hose of news and friends and data science and healthcare. And while I am interested in all those things, this combination without any organization just made me anxious no matter what was going on. These days, I also read as many newsletters as tweets, and I curate the sources that I'm paying attention to. When I moved into an industry data science role, for example, I asked coworkers for suggestions on how they keep up with the field. It's also important to triage what exactly to focus on. For me, first, our work is how we spend a lot of our lives, and it should be at least mostly fun. So if you really want to learn something, if you're excited about it, then excellent. Make it a priority, do it well. And there are also some foundational things that are useful, even if they're not as immediately exciting. Things like reminding myself periodically how linear algebra works. Those are good practice, even though it's not as fun as, for example, building an animated data visualization. There's always a cost, even to good things, and it's helpful to quantify that to yourself a bit. Will learning this new R Python library, will it be a useful addition to the project that you're working on? Or will the ones that you know get you what you need and this one just looks a little cooler? Something like learning Bayesian statistics is a good thing, but it's a major commitment. So if you're excited about it, how can you break it down into manageable chunks? How can you prioritize the time it takes? And what will you say no to in order to make progress? I've also been asking myself what I'll need to know now, soon, and possibly never. And saying never is not a value judgment about the thing. It's just a recognition of its value in my particular context. For example, for what my team at Devoted is working on right now, data engineering and analytics knowledge is super useful. We're building the foundations of our data work for the long term. So I'm really interested in learning the best practices for an analytics warehouse in our environment. But soon I'll need to dig back into my epidemiology and biostats knowledge. So I keep an eye on that as well as topics that are new to me and might be potentially useful, like Bayesian methods or natural language processing. Now, will I, in my current role, ever need to know about computer vision or neural networks? The likelihood for me, at least at this point, is low. So I try to devote less of my brain space to those things, even though I like knowing that they're there. So side projects are a really popular and extremely effective way to learn new things. And these have been so fun and useful for me in the past. I've gotten better at technical skills like version control. I've benefited from people with different perspectives looking at my work. And I've made connections that have really enriched both my career and my life by doing extracurricular work. But right now, I have no time or inclination for freelancing or learning starting big new projects. I work at a startup with plenty of intensity in my day job. But when I was getting a little itchy in my last job, I had way more motivation to do things on the side. And those things were actually really useful to me in figuring out my next steps and for getting me skills that were valuable when I took those next steps. It was actually a really useful signal to me that I needed something a little different in my day-to-day. In retrospect, I wish I'd listened to that signal a little earlier before I took on so much that I burned out a little bit. Which brings me to likely the most important point. It is so, so important to know yourself. What makes you excited? What gives you a sense of accomplishment and joy? And what makes you feel a little bit dead inside? And these same tendencies that color our attitudes toward methods or technologies can also show up in our career paths. I've learned from my own experience that it can be really useful to stay in a good job for a while. And it can also be useful to switch it up and get out of your comfort zone. In my own experience, the academic environment was a great one for me in lots of ways. It was especially good for the me that was right out of grad school to be in a place where learning and research are literally the goals and in-depth expertise is really encouraged. It allowed me to find my professional footing while doing some truly important work with good people. It also had a lot of benefits that translated more generally, assuming that the spot you're in is a good one for you, of course. I developed expertise, both on our research domain, which made my work faster and better. I was a much better collaborator at the end of my years with our group than I was at the beginning, both because I'd grown professionally and statistically, but also because I understood our clinical and our research goals. I asked better questions, I anticipated needs, I was able to contribute more to research design and execution because I had a deep knowledge of our clinical domain. I was also able to dig deep into the statistical techniques that we needed for our work, building my methodological knowledge base and developing credibility for myself in the academic community through that. And because our general tools remain consistent, I had the time to become an expert in them and bring innovations in open source software to benefit our research and operations. And also by keeping my place of work constant, I had the time and the brain space to explore related interests and new tools as I felt like it. In my case, that looked like side projects, the R community, and some nonprofit work. Change takes a lot of energy, even when it's good. And for a while, I was really happy to devote that energy to other things. And I was also able to build trust and relationships with both my supervisors and my collaborators. This is actually really huge because when you trust each other, you work together better. You produce a better product. You also communicate better. I learned how to communicate differently with different members of our team, so we worked better together. Let's see. And these relationships also make work more fun. Let's see. Sorry. But there can be downsides of staying in one place. At a certain point, I realized that I wasn't learning, or more precisely, Or more precisely, everything I wanted to learn just wasn't relevant to my daily work. There were tons of things that I wanted to build a knowledge base in, but those things were not things that were easy to use in my context. And of course, as we change and our life circumstances change, sometimes what worked for us in one season is just no longer doing it. The Jennifer right out of grad school loved the stability of academia. The Jennifer 10 years or so later was ready and itching for a little more variety. But on the flip side, if you have a lot going on personally, a job where you can get in the groove might be just the ticket after being somewhere like a fast-paced startup. And of course, sometimes you just need to change. That is scary for some of us and exciting for others. Maybe we've grown as much as we think we can in one spot, or maybe we just really want to move to a new state or try something different. So if you're ready, a new role can be really fantastic. Starting a new job, you will absolutely and inevitably learn. This was the biggest thing that I was looking for. I've already mentioned the new technology I'm learning. In addition to the tech side, I'm learning not only how to work with operational collaborators who aren't used to talking statistics, quote unquote, as much as my former collaborators were, but also all about the business end of healthcare, which is incredibly complex. And new people have superpowers. They ask great questions about why things are the way they are. They force us to disseminate that institutional knowledge that those of us who have been in one place have built. They bring different perspectives to things that other people have just gotten used to. One of the people who took my place in academics comes from a pharma role, and I'm told he's bringing some great ideas about organization and systems to my old research group that are really valuable, fresh perspective. Of course, building your professional and personal network is ideally both fun and useful. My new coworkers have a whole different set of perspectives than I'm used to. And the best part is that I still get to be friends and colleagues with my old coworkers. We build so many opportunities for collaboration and dissemination of ideas when we get out of our comfort zone. And of course, there's a feeling of excitement and energy when you start something new. Ideally, it's fun and rejuvenating. But like anything, there are some downsides. You lose some of that context and expertise that you spent time and effort building. And of course, how drastic this changes will depend on your specific situation. But for me, it's been pretty dramatic. I spent lots of years building up expertise in R. I've used R exactly once in the 10 months that I've been at Devoted. Instead, I've been learning data engineering, software engineering, SQL, and Python, along with the business end of healthcare, which is basically a wholly new domain. And it is a lot. It's exciting. It's exactly what I was looking for. And it's also really hard to go from feeling like an expert to feeling like a beginner in the space of one job change. And I told folks for my first couple months that I was used to feeling extremely competent and extremely useful in my previous role. And for a while, I felt like neither in my new one. And that's a scary feeling. It really revealed to me how much our identities are often wrapped up in our work. But the good news is that my career experience lets me know that I can learn new things. I will learn new things. And this feeling of possibly incompetence is temporary. To flip it on its head, it's kind of incredible to me to look back on the last several months and see how much I've learned. It's been very, very good for me to flex those muscles. It's a workout for my ego and for my brain. And it gives me a lot more empathy for others who are learning a skill or onboarding on our team. Of course, if you bounce around too much, it's hard to build that expertise in the first place. It takes a lot of time to onboard somewhere, on the order of months usually. So if you change jobs every 18 months, let's say you spend, half your time onboarding, it means that you essentially don't have the same amount of time to invest in your skills and expertise. So if there are pros and cons to both staying and going, how do you figure out which road to take? Well, of course, the short answer is it depends, but here's some questions to ask that I found helpful. What do you value? What do you want to spend your days and your career doing? And this might change over time. At one point, you might value professional development or your organizational mission over all else. And at another point, you might really value the stability that allows you to be present and provide for your loved ones. Figuring out what these values are for any point in our lives is a great first step. I knew from the beginning of my career that I wanted my work to have impact in the world. And I stayed in academics for a long time because I saw the impact that our work was having in the clinical realm. I saw medication use patterns change and awareness of certain conditions increase over several years based in part on my group's work. And that was incredibly gratifying to me. Thinking about moving from that to an environment where the primary goal was something like company profit wasn't very exciting to me. And in my case, that was more important than a moderate salary bump or getting to use a new tool. So having a good handle on that value really guided where I chose to spend energy and time looking for a new role. Also, what do you want out of something new? Do you need a whole new role to get it? Does that something new need to be a new job? Could it be a side project or a new role in your current job where you could just shift focus without needing to spend the time and energy restarting? You might see a job that sounds really fun, but if one of your frustrations is lack of advancement in your current role, and that job is for a sole data scientist at a small company, is that really going to give you what you want next? What are the trade-offs that you'd be making? For example, would you be getting a salary bump, but maybe losing the opportunity to use that expertise or knowledge that you've been working hard to build? Would you be getting prestige, but maybe losing time with loved ones or non-work things that you care about? How does quality of life figure into your choices? Essentially, we're always optimizing for something. So we need to clarify what we're optimizing for at any given point. So I hope this has given you some food for thought about how building a base of foundational skills and knowledge can be balanced with a healthy thirst for growth and adventure. And what that looks like will change for all of us. Knowing ourselves, what we're interested, what we're excited about, will give us such valuable insight into what directions that growth should take, when we should learn to stay, and when we're ready to branch out. So I'd love to take any questions or chat further.
Hi, everyone. So that was a terrific talk. So much to digest, both the math side of it and the long-term career stuff. I think, as was just mentioned, there will be questions, and there's a chat window. You can type them in there. I know we already have one from the floor, which is you talked about some of the side projects you undertake at work, and what is one of those side projects? How did it come up as a side project, and you know, was it worth working on? Can you tell us a little bit about it?
Yeah, absolutely. So I've got a few different examples. The short answer is they all kind of came up semi-organically just because I was paying attention, basically. The first one that I can think of is when a friend of mine and I organized an Our Ladies chapter in our city. Basically, Our Ladies was really taking off worldwide, and we thought it'd be really fun to organize a chapter. We were both really interested in building community and building our skills in that way, and so we started that, and it's been so fun. So that was one thing. It does take some time, so it's helpful to recognize when you have the time and interest in that, and when you don't. But it added nothing but great things to my life for sure. Let's see. Probably the next example is, let's see, a couple years ago, there was this volunteer organization called Data for Democracy that I just kind of saw on Twitter, honestly. And they were looking for volunteers, and I just investigated, and they had some different ideas for projects. And so I signed up, and long story short, ended up taking on a leadership role for a little bit in a project that was looking at prescription drug patterns in Medicare. And that was super fun because it involved a lot of people from all different backgrounds. There was an astrophysicist in our group, people who used Python, people who used R, people who were bringing all different perspectives from it. So that was really fun. And then I had a freelance project that I was approached to work on just as sort of an extension of the work that I was doing in my daily job. And it was really great. It was a very impactful project, but that is the one that probably in retrospect, let's see, it was a good project. I want to be clear about that, but it did take a lot of time. You're essentially adding a second job at that point. And so it felt like just not a break from work for me at that point. And so even though I'm really glad that the group as a whole tackled it and published it, I would think twice about signing up for something like that again, having experienced it once. So good experience once. I would weigh the consequences pretty hard before I did that. But that was an extension of the work that I was doing in my day-to-day.
Okay. Another question that was coming up. Ooh, this is a good one. It kind of circles around facing limitations while researching or developing a new way of thinking. How do you deal with feelings of failure and limitations of resources, especially when you're put in the context where you're jumping off, trying something new?
That is a great question, and we could talk about that for a very long time. Yeah, it's really a day-to-day feeling, right? Like there are some days when I come home from work and I'm like, yes, I was a boss today. Like I learned all kinds of things. And there are some meetings where I'm just like, I have no idea what any of these people are talking about. So it's kind of an emotional roller coaster. But what's been helpful for me is to take the time to reflect on how much you have learned. For me in these last several months, it's been a ton. It's been so much. And so during those meetings where I feel a little lost, it's helpful to reflect back on like, I knew the answers to questions that in January, I wouldn't even know what the question was. So remembering what you have learned and what you're capable of learning is really helpful. And also just finding really helpful colleagues or supportive people to bounce ideas off of and, maybe you're doing better than you think you are, or maybe they have an idea about where you can go to learn the thing that you feel like you're failing at. So supportive community is really huge, I think.
Alrighty, so we have a slightly more specific question regarding your presentation, which was, can you tell us what the results were about the drugs from the ICU study?
Oh, the last one. Yeah, absolutely. That study was so interesting, and the paper was published in the New England Journal, so I'd encourage you guys, if you're interested, to go find it. But basically, we found out that neither one of the antipsychotics that we were looking at, in terms of what we looked at in terms of outcomes, neither one of them was remarkably better or worse than just a placebo. So we still don't have a great treatment for delirium unless they found one in the year since I left. So, you know, which was actually a really interesting finding, because it led our group and others to shift more on prevention. Like, how, if we can't treat it well, how do we prevent it from happening in the first place?
Alrighty, well, I think we've hit 3 o'clock. So I think, sorry, one more question from the floor. So it is the ability to communicate results, particularly through writing, is obviously pretty important in statistically inclined fields. And one of the best ways to improve one's writing is just to go read others' work. Like you said, one of the best ways to learn a coding package or whatever is to go to a tutorial, kind of the reading equivalent there. Who are some authors, some statisticians, writers who you would recommend reading so we can improve our own statistical writing?
Oh, wow, specific people. That's a hard one. Let's see. I'll tell you a story to kind of answer that question. There is this guy named Nick Tierney. He's a friend of mine. He's in the R community, and he had written a blog post that explained a certain concept in R. And I'm not sure how much detail to go into. I'm not sure who's using R versus some other software package, but basically he had written this, and it was explaining like S3 classes, which are kind of this fundamental how does R work thing. And it wasn't as complex as a journal article or something like that, but he wrote that blog post and I was like, I immediately understand this. And so to me, like, searching out blog posts from people like him who are like, I've just learned a thing and here's what I've learned about the thing, that's been incredibly useful versus digging into like more theoretical books or more, more in-depth journal articles, for example. That's not exactly an answer to that question, but hopefully it helps a bit.
Definitely helps a bit. Well, since it's approaching 3 o'clock, it is 3 o'clock. I think we're going to wrap up now. But again, thank you so much, Jennifer, for sharing your perspective. I know that, especially for undergraduate researchers, just like learning about how to build that confidence when you're going into trying new things is just, it's reassuring to hear someone sort of bring that perspective forward. So, and also thank you to those who are listening. We want to thank the sponsors of EUSR, the ASA, Cause, Google, RStudio, and the ASA section on statistical education. And our next little segment is going to be turning it over to a graduate school information session. So stay tuned for that. Thank you again, Jennifer, so much.
Oh, thank you guys so much for having me. It's really fun.